Okay. All right. Well, good morning, everyone, and welcome to the North Central Field Winter Meeting 2021. It's a great pleasure for me to welcome you all. You may not recognize me. I am new in the department. I'm Raj Khosla, new head of the Department of Agronomy at Kansas State University. I come from not too far from Kansas. I've been at Colorado State University for the last 20 some years. And prior to that, I was in Virginia before my family and we moved to Colorado. And I am not new to Kansas because, if I look back at my career, I've had research, teaching, and extension appointment. And I have been to Kansas many times before, talking at extension meetings. I've not been to Sandier yet, so I need to make it there sometime. But very excited to see all of you joining on this beautiful morning. There's snow on the ground, at least in Manhattan right now. And so it's a great pleasure for me to be here. I'm here to learn and listen what Scott and Sarah and Romulo and others have to share at this extension meeting. So with that, what I want to do now is I would like to introduce Scott Dooley. It is my pleasure to introduce our assistant agronomist, who is also agronomist in charge at the North Central Kansas Experimental Field. Though Scott is new in this particular position, he has a long history with K-State. He started his position as assistant agronomist and agronomist in charge for the North Central Experimental Field last summer. He grew up right here in Kansas on his parents' farm in Jewel, Kansas, which is only 35 miles from Sandier. And he has been a strong supporter of KSU. He earned both his bachelor's degree in agronomy in our department, as well as a master's degree in agronomy, focused on cropping systems. After he got his degrees, he spent the next 10 years working for Mike Stam. I noticed Mike is also joining us today, working with him at the K-State canola breeding program for the last 10 years. And among many locations that his graduate work brought him or took him to places included North Central Experimental Field, so right here. And in fact, he was telling me that the canola breeding plots have been on the station as well. So he feels like he has already spent several years working at the field already. He knows the place quite well, so that's fantastic. And Scott has also worked with several faculty members from our department, as well as faculty from other departments at our university. So I totally agree with him that our future looks bright. And with that, again, for those who joined a little bit later, I am Raj Khosla, who's the new head of Agronomy Department at Kansas State University. It's a great pleasure and honor for me to be part of the K-State family. And with that, I'm going to pass the baton on to Scott. Scott, the floor is yours. Thank you.
All right. Thanks for the introduction, Raj. We're certainly glad to have you here in the department. Raj told me that he's got another meeting to attend later today, so he won't be able to stay the full time, but we're glad to have him here as long as he can be. To start off with, I'd like to give a short update on our field activities and what we've got planned. As many of you know, fall harvest went well in the area. Yields were great. We were thankfully able to collect data off of all of our variety performance trials this year. The corn, soybean, and grain sorghum results are available online if you haven't seen them yet. Hopefully the full publications should be coming out soon. And I can drop a link later in the chat box to this website. We've got several trials planned for the coming year. We're hoping to continue the variety testing for the corn trials, the soybeans, wheat, grain sorghum, forage sorghum, and canola. Both the corn and soybean trials will have both a irrigated and dry land site as they have in the past. We'll have several soil fertility trials. Most of them we'll host, others will conduct the trial. We do have a long-term phosphorus management trial on the station though, that we will be continuing. It's in a corn soybean rotation and has been ongoing for a long time now. We're hosting 2 different cropping systems trials on the station. There's a corn soybean rotation trial that's got both a dry land and irrigated component. And there's also a corn field pea wheat rotation here on the field. And we're also conducting a cover crop trial that is looking at grain cover as well as the biomass production. We're using a phone app to collect the cover data. We'll take pictures of the plots in color as you see on the left, and the app converts it to a black and white image on the right, then lets it calculate the green cover. And hopefully this will be a multi-year trial. If you've got any questions, you can ask those now. Otherwise, feel free to take down my contact info, and I would certainly welcome any questions, suggestions, or feedback on the field activities that you might have. I'd like to thank you for joining in this morning. One nice thing about the virtual format is that when it's snowy outside, we don't have to worry about traveling. We can just join in from wherever we may be. As we go along, there will be plenty of time for questions. You can either type those into the chat, or after the presentations are over, feel free to unmute yourself and ask your questions as well. And I think with that, we will move ahead with the presentations. Romulo Lollato will be speaking first, and then Sarah Lancaster will finish up. So thank you for joining in again.
Scott, I have a quick question for you. Is it okay to ask?
Yeah.
So what app was that that quantifies the vegetative biomass?
That is called Canapeo. It was actually developed at Oklahoma State University.
Okay, all right. And is it available free for everyone?
Yes.
Okay, okay. This is something I'm very familiar with the process, but because they have an app and they have simplified the process, it got my attention right away. Thank you.
Yeah, it's very quick and easy to use.
Okay, nice.
Okay, very well. Well, good morning, everyone. It's really good to be here with you today. I see a lot of names that I know in the participants here, including Dallas. Dallas, good to see you. We always travel together for the last 5 years for this meeting. So yeah, with the amount of snow that we got here last night, it's good, as Scott mentioned, not to need to travel. So yeah, good morning, everyone. Very good to be here with you today. And today, some of the things that we're going to cover are some of the research projects that we have going on in North Central Kansas. So I'll go ahead and I'll share my screen here. There we go. And really my idea here today is to share some of the research that we have going on in North Central Kansas, not only at the station, but also some things that we're learning from the farmers in the region, right, in commercial wheat fields out there. So essentially, we're going to start off this presentation with what we're learning from farmers, right? This on-farm survey that we conducted for 3 years, and part of it was conducted in North Central Kansas there. Then we move forward to, okay, we learned some of the things here from farmers. How can we expand on that with our small plot research? And that's when I'm going to share more data from things that we're learning from the North Central experiment field, both on the fertility trials that we have going on, as well as small plot fungicide management trial, and how fertility and fungicide interact with variety selection for wheat. So folks, moving forward here in our on-farm survey, essentially what we were doing here was sitting down with farmers and trying to learn from field-specific data on what they are doing in each one of those fields that they are managing, right? So just for example, this is what a form looked like for a farmer who has provided information from 4 different commercial fields, right? You can see here that we're asking about the planting date of that field. We're asking about variety selection, seeding rate, tillage practices, and so on. So essentially, we're trying to get a hold of the information for field specific, right, all the way to fertility management, fungicide management, harvest date, grain yield, and if available, we were asking for protein content as well. So essentially, again, this is looking at research from a little bit different angle. Instead of going out and putting several replicated plots, we are going and asking farmers what they are doing, trying to get data from enough growers out there that we can actually try and learn something after with all that data in hand. And essentially, briefly here, if you take a look at this map, what we have here in green is the wheat area in the state of Kansas. In yellow are all of the fields, individual fields that we collected data from, right? So you can see here that for the north central part of the state, we have a good number of fields up there. And if we look at the yield levels across all of these close to 700 commercial wheat fields that we collected data from, you can see here what we're looking at in this graph is in the bottom we have the grain yield level of all those interviewed fields, and in the left hand side we have how many fields were in that yield category. So you can see here that we have 1 or 2 fields that were very low yielding, about 5 bushels per acre, and 2 or 3 fields that were very high yielding, over 100 bushels per acre up there. But in general, we had a pretty good distribution of yields with an average of about 57 bushels per acre, and half of our fields were yielding between 45 and 70 bushels per acre. So this is the yield level that we're working with in all of these fields that we actually had across the entire state. Now, as you're familiar with Kansas weather, it changes quite a bit from north to south to east, from east to west as well. So the first step that we did whenever we're trying to understand a little bit better in farmers' fields what practices are more related or less related to yield was to divide these fields in 3 big regions, right? So we collected data from 2016, 17, and 18, and we divided these fields into the north central region, west region, and south central region. And you can see here in the west is a drier region, less than 24 inches of precipitation in the year, and a relatively cool region as well. North central, another cool region as well, but more precipitation, 24 to 35 inches of rainfall per year. And then south central, which is about the same amount of rainfall as we had in north central, but warmer weather. So for the remaining of this presentation, we're going to focus only on what we can learn from the north central region of the state here from growers' fields. So the first thing that we can learn here is what is the average adoption, right, of management practices on these commercial fields, or in other words, how are our growers managing their wheat crop? And that's what we're looking at here in this table. So we have here the average adoption, either rate or day of the year, or depending on the variable that we're looking at, of different management practices that we were collecting in this survey. So, for example, what's the average sowing date in that north central region of the state? This is October 10th. That's the average of all the fields that we were interviewing at an average seeding rate of 83 pounds per acre. And then we go down here, we have a total nitrogen rate of about 88 pounds of nitrogen per acre. And we can see here that about 55% of the fields included in this survey were actually spraying a foliar fungicide around heading. So this is the first thing that we can do with this data, is try to learn what are our growers doing in the different regions of the state. And later, maybe more interesting, just as interesting, is how are these practices related to yield in this region, right? So let's just briefly go into that before we get into some of our small plot research. And this is one example. So we can look at the sowing date of all of those fields that were in north central part of the state. And here the frequency, so how many fields were planted at those dates. We see here that we had fields planted as early as about September 20th and as late as about November 2nd. The majority around here, October 10th, which in this graph would be here on day 40, right? We're looking at sowing date. And the unit here is days after September 1st. So 0 here would be September 1st, 40 would be roughly October 10th. So this is the distribution of our planting dates in these fields. We see here several fields that got planted in September. These are typically fields that were planted in a fallow situation. And as we go later, we have more fields that were planted after soybeans. Now, can we learn anything from planting date and grain yield? And so if we look very briefly at this snapshot here, again, we still have that sowing date in our bottom axis here, but on the left axis now we have grain yield. So, for example, this field here would have been planted about September 25th and yielded just like 5 or 10 bushels per acre here, pretty low yield. So the message from this figure here are two. First, if we're shooting for yields between 40 and 60 bushels per acre here, there's really no relationship there, right? I mean, it's kind of like a scatter, like a shotgun type of graph here, not much relationship. If we're just looking at the highest yielding fields, right? So if we just selected those highest yielding fields and try to learn something from them, and we assume that they were not limited by other things, so we assume that that's the potential that we could reach in that region. We have here that our peak was about October 10th, meaning that if we could plant all of our fields in one day, we want to be around that October 10th, maybe a few days earlier, a few days later there. And if we're going too much later, so if we're going after October 20th here, we have a pretty steep decrease in our yield potential, right? If we assume that these fields here were not limited by other things, by management, right? They were very high yielding fields. We're actually losing, by delaying our sowing date, about 2 bushels per acre per day in our yield potential. Again, the grower is shooting for about 40 bushels per acre, probably doesn't matter much, but if he's shooting for higher yields, this yield loss is important. Kind of a similar way that we can look at this data is just looking at the nitrogen, right? So here we have the amount of nitrogen that were applied in these several fields in north central Kansas, and how many fields applied that amount of nitrogen. We see here an average about 92 pounds of N per acre, ranging from about 20 to about 190 pounds of nitrogen per acre. Now, if we look at that same next plot, right, we just look at the nitrogen rate and grain yield here, we essentially have a graph that we could divide essentially in two different parts here. On the left hand of these roughly 100 pounds per acre here, fields were likely limited by lack of nitrogen, because as we increase the amount of nitrogen being provided, we also had a response in that potential yield, right? So those fields that were using the nitrogen more efficiently were increasing yield as we increased nitrogen availability. And after that, about no relationship there. And then the other thing that we can ask ourselves here is these fields that were more efficient, how efficient were them? And we see here that these fields were actually being able to produce about 0.8 bushels per acre for every pound of nitrogen that was applied. Now, let me pause here real quick, because this seems like a very high nitrogen use efficiency, which it is. Our recommendation is that we needed 2.4 pounds of nitrogen for every bushel per acre yield goal that you have. And so why are these fields so efficient, right? And a couple of different things that might be going on. First, they might be mining nitrogen available in the soil, right? Some of these fields here might have north of 80, 90, 100 pounds of nitrogen available in the profile. And so when we just look at the nitrogen rate applied, might not be a very fair comparison there. And second, if they were able to provide more, to produce more yield with less nitrogen, well, very likely they are probably resulting in low protein concentrations. So somewhere it needs to give, right? If they're applying less nitrogen than what the crop actually needs to sustain 12% protein, very likely we're resulting in a low protein crop. So another thing that we can do with this type of data that we're trying to learn from growers is separate growers into high yielding fields and low yielding fields, right? So if we actually get all of these fields that we were looking at in north central Kansas and look at the 30% highest yielding growers versus the 30% lowest yielding fields, we can start to compare adoption of management practices in each one of these groups, right? These two very contrasting groups. And that's what we have here, for example, for sowing date. We can see that the low yielding fields that are always going to be the light purple bar, they were being planted about 3 days later than the highest yielding fields. So something here is indicating to us that those higher yielding fields were being planted on average about 3 days earlier than the low yielding fields. If we look at rotation, for example, we didn't see a significant difference in the wheat crop going after soybeans, although there was kind of like a signal there. You see that in the low yielding wheat fields, about 70% of them were planted after a soybean crop, which really pushes the planting date of the wheat crop later, right? And so we're kind of delaying that entire developmental cycle, right? We're delaying the entire cycle of the crop, putting the crop into probably a soil with less water and a cooler soil as well that allows for less tillering as compared to those higher yielding fields. And if we look at a previous crop of fallow, right, so a crop that is going after a long-term fallow there, we had slightly more after on the high yielding group. About 16% of those high yielding fields were being planted after fallow, only 2% in the low yielding fields. And so we can do this for several things. If we compare the adoption of seeding rate in the high yielding fields versus the low yielding fields, seems like the high yielding fields were slightly lower on seeding rates. Again, when we look at farmer data like this, there is the confounding effect of they were also planting earlier, right? So we cannot say that yields were higher because they were planting at a lower rate, because there are some confounding effects. But we can start just comparing these groups and seeing how higher yielding fields were being managed in comparison to lower yielding fields. Adoption of insecticide seed fungicide seed treatment was higher in the higher yielding groups. Adoption of insecticide seed treatment was also higher in the high yielding fields. Nitrogen rate was averaging about 100 pounds of nitrogen per acre in the high yielding fields versus 73 pounds per acre in the low yielding fields. So another signal there that nitrogen might have been limiting in these lower yielding fields. And foliar fungicide was also another striking difference there. So much more frequently adopted in the high yielding fields. About 75% of those high yielding fields were adopting foliar fungicides as compared to 36% of the low yielding fields. So far we're just looking at independent management practices, right? But remember that this is all collected all together, right? Growers managed each field, each yield level that we had actually had a series of management practices adoption with them. So how can we try to learn from putting all of these together, right? Putting all of these management practices together and seeing what is truly or what is more related to yield in north central Kansas. So that's why we're looking at this last graph here. And I'm going to just briefly explain what we're looking at. Essentially, we have all of those fields being affected by all of the management practices that we asked about. And the number that you see on the bottom here, just on top of this each little chart, is differences from the mean, right? So of all those over 250 fields that we had in north central Kansas, they have an average, for example, that average of 57 bushels. So if this is less, minus 13 here, it means that these fields are averaging 13 bushels below the average. So looking at all the management practices together and how they were related to yield, in north central Kansas, the total nitrogen rate was the most important factor affecting with yields. So in fields that were actually receiving a total nitrogen rate of more than 125 pounds of nitrogen per acre, they were actually yielding about 13 bushels per acre above the average of all of those fields. We also had some yield benefits or yield associations with insecticide seed treatment. So fields that were applying insecticide seed treatments yielding slightly more, and flag leaf fungicide as well. So fields that were applying flag leaf fungicide yielding more than the average of the region. And then the lowest yielding fields of all of these fields that we interviewed in the region was those that got less than 87 pounds of nitrogen per acre and did not got less than 13 pounds of phosphorus per acre as well. Usually applied as a starter fertilizer or before or a broadcast incorporated pre-plant. So again, this kind of tells us a few signals here that nitrogen was very important in these commercial fields, insecticide seed treatment, flag leaf fungicide, and management of phosphorus as well. So very briefly here, folks, some take home from this first portion of the presentation that we're just looking at the on-farm survey here. Sowing date was important in the region whenever it was affecting the yield potential, right? Not necessarily the average yields of most of those farms, but the yield potential, with a yield penalty of about 2 bushels per acre per day if we are delaying past October 15th to October 20th, pretty steep yield loss in potential there. Higher nitrogen rates were adopted in the highest yielding fields, as well as more frequent foliar fungicide applications and seed treatments as well. Now, with this in mind, we went ahead and started several research projects looking a little bit more in detail into some of these things that are affecting yield in the region, right? Nitrogen rates and how it's interacting with variety, foliar fungicides and how it's interacting with variety. And this is what we're going to focus on the last part of the presentation here. We also have a large project on seed treatment where we're conducting in over 10 locations per year. We're not going to cover it in this presentation. So folks, here's where I'll switch gears a little bit. So far, we're learning from growers, seeing what we can learn from commercial wheat fields. And now we're going to move to the small plot research that a lot of this work has been done in the North Central Experiment Field in Belleville, but in other locations across the state as well. So first focusing on the fertility research. Right, nitrogen was a pretty big factor, a very important factor on those commercial wheat fields. So we're going to focus on nitrogen first. It seems like we have a question there. I'm not sure if I can. Scott, can you? Gary.
Hey, good morning. How are you?
Very good. How are you?
I'm great. It's been a long time since I've spoken on any of these meetings, but I'm all about timing on that nitrogen because I think that you're all over the idea of more N equals more yield. And I'm trying to get away from my anhydrous program, which I'm in love with. And so do you have any data, or maybe I'm jumping ahead because I ran out there and threw some more on right before the snow, and I think that might have worked out. But do you have any hard and fact information that splitting it up into 2 or 3 applications might benefit versus the anhydrous route?
Yeah, that's a very good question. Anhydrous usually is a pretty good strategy, especially if you're grazing or something along these lines, where you really need all that nitrogen early on for production of biomass. But it's probably going to be less efficient if you're in a grain only situation, and especially if you need to wait until you harvest soybeans before you plant the wheat. So we do, I don't have that data here, but I can briefly discuss with you. We had several years of research where we're trying to do 100% in the fall versus 100% in the spring, and that's a little bit later than now. I was probably going at whenever it's breaking spring dormancy. And you know, if you are like in your region where you have a lot of wheat after soybeans, that either concentrating either 100% in the spring or a split of 40-60, where 40 in the fall, 60 in the spring, and I'm talking about percentage here. that was actually yielding considerably more and using nitrogen considerably more efficient than putting it all in the fall. Although we were using UAN for all of that project. We're not comparing with anhydrous. We're using UAN for all of that project. It's a very good question. If we think physiologically, the wheat is determining the head size now sometime in the spring, early spring, between that beginning of stem elongation by the first joint. So by that first joint, you already kind of have defined the head size. So essentially, that's where we want to make sure that the plant has it already, right, by that jointing. After that, it might still affect you to some extent, but it's more going to be focused to protein.
Well, it's kind of hard to get excited about putting a lot of N on wheat that's barely came up. And so I don't know how you can push this wheat along to get it moving, but I mean, obviously it's pretty nerve-wracking to see some wheat that's up and other parts of the field that are still trying to come up at this point. And I'm sure you're seeing that all over your area that you travel.
Yes. Yes, we had such a dry fall there, that October timeframe. We essentially had almost no rainfall other than some rainfall in September in the western part of the state. So yeah, a lot of very small crop just coming out after that early November rainfall, and then it got cold. And so yeah, I completely understand. You have a small crop, it's not uptaking a whole lot of nitrogen yet, and kind of afraid of putting it out there and perhaps losing to the environment. So yeah, I understand your concerns. But again, if I would...
Sorry, but is there anything besides nitrogen that you'd recommend me tossing out there to try to encourage this wheat to maybe tiller a little bit more at this point? Because, I don't really know of anything else. I mean, you can't really put phosphate out there. I mean, I've already got sulfur down and phosphate and zinc with my starter, but is there anything else that we could do to try to increase our tiller counts at this point?
Well, at this point, if you already did, as you were mentioning there, you had starter fertilizer, and I'm assuming that you also had a seeding rate on point, knowing you. And so, yeah, at this point, nitrogen fertility is probably what we're looking at. I'm going to discuss a little bit of sulfur fertility here as well. And that goes on with the nitrogen, but I think those are the two that I'll be looking at right now. At this point in time, as you mentioned, probably not worth to put any phosphorus out there. Should have been put with the seeds. So.
All right, thank you.
Yeah, great questions. Thanks, Gary. Okay, folks, so we'll move on here briefly to just some fertility work. If we have time, then we'll go over the fungicide research as well. But feel free to raise your hands and ask questions at any time, and we'll go along with that. So, okay, so some of the fertility research. So first, I'm going to focus on the nitrogen piece, and then I'm going to move on to the sulfur piece, as I was mentioning here. So this last year, based on some of this research, the results that we had from farmers, we went ahead and we put an experiment here where we were looking at 14 different varieties, as you see listed there, in 4 different nitrogen rates, right? 0, 40, 80, and 120. And we were wanting to see, do these varieties respond differently to nitrogen or not? So we had 4 locations this last year, and we had another 4 locations going on this year. Pretty big trial. And you can see here that for last year, we had our initial soil nitrate ranging from about 20 all the way to 172. And so we really need to consider that in our nitrogen decisions, right? What's the initial nitrogen in the profile that we have? Because for those fields that have 110 or 192, you're going to need a much different amount than those that we had 20 or 24. But moving on to what we found this last year, again, from these 4 locations that we had this trial, yields ranged there from about 20 bushels per acre to close to 90, with an average of about 50 bushels per acre. So that's the yield levels that we were looking at. And if we look at how the crop responded to nitrogen visually, in those locations that had very limited nitrogen to start with in the profile, this is a picture that we took in Sumner County. So the responses were similar throughout the state whenever nitrogen was limiting. For example, for this variety, Westbred 4269, comparison of 0 pounds of nitrogen per acre on the left-hand side. You can see a much limited biomass, a much lighter green color as well. versus the 120 pounds of nitrogen per acre here. Now, keep in mind that both of these plots received 20 pounds of sulfur. So we made sure that sulfur was not limiting here. So the difference here is just limitation for on nitrogen for this crop. And if we looked at the same variety later in the season, like closer to harvest maturity, and this is in Ashland bottoms here, actually during grain field, not harvest maturity, sorry, during grain field, we also see a very similar response to nitrogen, right? Much thinner crop, much less biomass, many fewer heads per square foot there, as compared to a much lusher crop, many more heads out there with the 120 units of nitrogen per acre. So Gary was mentioning that a lot of my research was showing here that more nitrogen, more yield, and that's what we're trying to figure out here. Is that really true, or where's that break point, right? And so whenever we plot the yield levels that we were seeing in this last year against the total amount of nitrogen available, okay, so again, this is available, this is not the amount of nitrogen that we applied. So in that soil that had 170 units to start with, the zero nitrogen will be somewhere around here, okay? We against grain yield, we kind of have two clear yield environments here, right? We have a higher yield environment and a lower yield environment here where nitrogen was maximizing yield at different levels. So let's break down into these two different environments, low yield environments, high yield environments, and let's see how varieties differ in their response to nitrogen. So essentially, if we look at the low yield environments here, we're looking at yields that were maximizing at about 40 to about 50 bushels per acre here, right, in this graph. And so we have a couple of things in this figure here that are interesting. First is the breakpoint. And the breakpoint here was 102 pounds of nitrogen per acre, for example, for Bob Dole, maximizing at 47 bushels per acre yield. For 4269, about the same thing, right? I mean, just a little bit more nitrogen there, a little bit more yield as well. So very similar here in the low yielding environments. Now the question is, when we went to a much higher yielding environment, were they still similar? Right? And what we see here in that high yielding environment is that the breakpoint for Bob Dole was about 200 units of nitrogen available, again, soil plus what we applied, at 64 bushels per acre. And for 4269 was slightly more nitrogen needed there, but a much greater yield, right? And honestly, if you look at these 2 points here, we needed about the same amount of nitrogen for a 20 bushel per acre yield difference there, right? So the question that we have now is, do all varieties, did they have the same nitrogen requirement? That's what we're looking at here. Where is that yield plateau? So where did that variety maximize yield in the high yield environment, and how much nitrogen it needed? So you can see here that the yield plateau ranged from 64 to 84 bushels per acre, and that nitrogen requirement ranged from about 200 to about 250 pounds of nitrogen per acre available, okay? And in the low yield environment, the ranges were much narrower, right? We had 42 to 52 bushels per acre yield difference between the highest and the yielding and the lowest yielding variety, and about 40 units of nitrogen spread here. So the next question that we had here is, are varieties that are yielding more also requiring more nitrogen to get there, right? And that's what we have here. We have that nitrogen breakpoint for each variety. So each one of these points here is one of those varieties that we were looking at, and where that variety plateau, what was the maximum yield for that environment. In yellow, the low yield environment, in blue, the high yield environment there. So essentially, we didn't find any significant relationship here. What does this tell us? This tells us that, this lack of relationship between how much nitrogen the variety needed to reach there and how high that plateau was, is that either we have varieties with different nitrogen use efficiency, or some of these varieties have less protein, like a penalty in protein there, and that's why it's able to produce more yield with the same amount of nitrogen. One of the students is now processing the protein data, but we can briefly discuss the nitrogen use efficiency data here. And so whenever we look at the nitrogen use efficiency across all of these 4 locations that we had, all the nitrogen levels that we had, the more nitrogen we had available, the less efficient the wheat crop was able to produce. So here we have bushels per acre per pound of nitrogen available, right? So in the low nitrogen environment, it was as high as about 60%. In the high, as we increased the amount of nitrogen available, our nitrogen use efficiency decreased. So that was the main factor limiting our nitrogen efficiency, is just like how much nitrogen we had out there. But are there differences between varieties? And that's what we're looking at here, is the nitrogen use efficiency of each variety after we corrected for the amount of nitrogen available. And essentially in blue here, we identified a couple of varieties that seem to have a higher nitrogen use efficiency. In yellow, as compared to the ones in yellow, right? And the ones in green, they were in between, right? There were varieties that were similar to the low nitrogen use efficiency ones, similar to the high nitrogen use efficiency ones. So there is some signal there that the varieties are different in nitrogen use efficiency. We're actually now, the goal is during this winter to really crunch this data and make sure that we can, what all we can learn from this data and how varieties are different. And continuing this research, which has been sponsored by the Kansas Wheat Commission in this year to come as well. Now, this is just nitrogen rate. We have work on nitrogen timing as well, which is important. I'm not going to be able to cover it here today. But very briefly, I want to talk about a different nutrient that Gary alluded to there, which is sulfur, right? Because nitrogen doesn't really tell the full story. Very briefly here, why we want to cover sulfur as well, right? If we look at this figure here from Mary Gutierrez from the USDA, in purple, we have the sulfur that is being deposited in the rainfall. In yellow, the sulfur that has been deposited, harvested in the wheat crop since 1980s, okay? What we see is a negative trend in what is coming down in the rainfall. So with the Clear Air Act, right, we have less sulfur being emitted into the atmosphere, and so less sulfur coming down as well. And that really results in a gap, right? Since about the early 2000s there, we're likely mining the amount of sulfur that we have in the soil. So more and more common for us to see some sulfur deficiency in wheat fields as we travel around the state, especially true if you are traveling around that early green up phase, like March and early April there. Very common to see this type of scenario where you have this lighter green, and if the sulfur deficiency is really steep, then this actually comes also almost to a brighter yellow color. So it's very typical. And the way that we differ this from nitrogen deficiency is that sulfur is going to occur typically in the upper leaves because it's not mobile in the plant. So the upper leaves are the ones that are going to become yellow first. Whereas nitrogen deficiency, it's mobile in the plant. The deficiency starts, the plant starts translocating from the older leaves to the new ones. So very common to see this around Kansas more and more in recent years. So we went ahead, and again, with the support from the Kansas Wheat Commission and Graincraft here as well, we put out a trial that we have a 3-year data for it now, where we're looking at the interaction of nitrogen and sulfur, right? So the nitrogen rates that we're looking at were for a yield goal of 60 bushel per acre. So essentially the total nitrogen that we had, 60 times 2.4 is about 140 units as total goal of nitrogen in that location, considering the amount of soil nitrogen that we already had there as well. So we're either putting 50%, 100%, or 150% of that goal. And this was applied as UAN in the spring. Same thing with sulfur. We had 0, 10, 20, or 40 pounds of sulfur per acre, which was applied as thiosol early in the spring as well. And we're looking at varieties that were differing in nitrogen use efficiency. So the last 3 years, we conducted this project in several locations across the state. And these locations had contrasting soil texture, contrasting organic matter values as well. So if we focus on some sandier soils with low organic matter, okay, important to highlight this, some sandier soils, lower organic matter. This is the type of visual response that we were having in these plots. Okay, so these two plots, they received the exact same amount of nitrogen fertilizer, but they were differing either in 0 pounds of sulfur being applied or 100 pounds of sulfur per acre being applied. And you see here the level of deficiency that we had in some of these soils. right? And also how, I mean, we don't need much to overcome this deficiency, right? And it's causing a lot of yield loss through less biomass, less tillers out there. Very similar scenario if we move closer to mid to late grain filling here. The left-hand side again, our zero sulfur in this sandy soil, low organic matter. You can see how few heads we have out there, not much biomass as compared to the neighboring plot. That the only difference here were 20 pounds of sulfur per acre. Again, low organic matter, sandier soils. This is the type of response that we were seeing in the field. So let's take a look at grain yield, right? And how grain yield was responding to nitrogen and to sulfur. So this is what we have here. We have on the bottom here, we have the nitrogen rate. Again, that percentage of a yield goal for 60 bushel per acre. 50%, 100%, and 150%. And we have grain yield on the left-hand side. And we have 4 lines. So let me go over these lines with you. So let's talk about the solid black line first. This is the 0 pounds of sulfur per acre. So no sulfur at all in a low organic matter site, very sandy soil. First thing that we see here is that we can increase our nitrogen rates. And essentially we had very limited to no response to nitrogen if sulfur was deficient, right? In a very deficient sulfur situation, we could be putting 70, 140, or 210 units of nitrogen out there total, no response at all. Now let's look at the red line, right, which we're just adding 10 pounds of sulfur per acre. In this very deficient situation, the first thing that we see is this jump here in grain yield, right? So the red line is much higher than the black line, meaning that we have that yield gain from that sulfur in a deficient situation. Not only that, that sulfur also allowed the crop to respond to the nitrogen rate to a certain level, right? We increased our nitrogen rate here, grain yields increased, and then it kind of leveled out. And then we look at the other 2 rates where sulfur was not deficient, and essentially we had kind of a linear response to nitrogen there. So it allowed to improve yields even further at our highest nitrogen rate. So again, this interaction of nitrogen and sulfur rate, we were able to find it in these low organic matter sandier soils, where 2 things for us to take home here. First, no response to, well, first, much lower yield levels if sulfur was deficient. Second, no response to nitrogen if sulfur was deficient as well. Then once we provided sulfur, we took care of those 2 things, increased yields and also allowed for a response to nitrogen. And this was very consistent. This is another project which was using urea ammonium sulfate or urea, so dry fertilizers here. Very similar response, right? So I'm not going to spend much time here just because the response was very similar. Just want to show because it is consistent. Now, we look at a soil with a better organic matter content, right? Maybe a silty, in this case was a silty clay loam, but we also had this Triumph Bellevue with silt loam soils up there. Then we're not seeing much benefit from the sulfur, right? What you can see here is that there was a very clear effect of nitrogen. As we increased nitrogen, we were increasing yields as well. But sulfur was really not limiting, probably because a lot of that sulfur was coming from that 2.5% organic matter that we had in the soil there. So take home here from the sulfur trials and the nitrogen trials that we had is that really we saw no response to nitrogen when sulfur was limiting the crop yield. Generally, we had a greater likelihood of yield gain from sulfur if we were in those low organic matter sandier sites, and not much response to sulfur in higher organic matter type of soils. Varieties differed in their response to the nitrogen piece, but not necessarily in response to sulfur. And the fertilizer sources that the 2 different studies were comparing, right, they kind of provided similar responses there. So from what we have now, we can say that the nutrient itself was more important than which source we were using to put that nutrient out. So folks, I had planned on a 3rd portion here where I'll cover fungicide, but I think I'm running out of time. And so I'd like to actually open for questions if there are any at this point. And I will share these slides with Scott. And so he could share with you, and most definitely you could email me any questions or reach out on Facebook or Twitter if you have any questions about anything that was covered here, or the fungicide piece as well, which we didn't have time to cover, but I would be happy to answer any questions there if there are any. And Scott, I'm not being able to see the chat. So
Hey, Romulo, can you hear me?
yes. Hey, Nathan.
Yeah, hey, great presentation. I'm glad I was able to join. I remember doing research at Belleville and Scandia. All of your information you shared is matching up with my observations on planting date for October 10th that I looked at with new weather data, the nitrogen rate, and even the sulfur. So it's glad to see what I've seen and observed from farmers here in Southeast Nebraska match up pretty much exactly with what you showed today. So I appreciate that.
That's awesome to hear. Thank you for the comment there, Nathan. And it's good to see you online there. We didn't have the chance to interact in the other meeting that you were putting together, but I'm happy to see you online there. So thank you. So we have a few questions on the chat here that I'll try to address them. So Sandra here was asking to provide an update on the wheat crop and crop potential at this point. Yeah, she made a comment here, very small and little tillering, and that's completely true. I think for a large portion of the state, you know, the fields that were planted relatively early, so in that late September time frame, and were able to capitalize on some soil moisture that was there at that point in time, especially in western Kansas, but some fields north central Kansas as well. They had a good potential kind of going into the winter. It dried out later, so that was a little bit of a concern, but at least they were able to emerge and still put out some tillers during the fall. Now, the majority of the fields that were actually planted so after soybeans, right, in this region, north central Kansas, we didn't have essentially any rainfall there throughout the month of October. There may be a little bit of rainfall there in early November, but not much. So the emergence has been a little bit more scattered and not a lot of yield potential there. So Sandra, that's a great question. The way that we look at this is the later the emergence date, right? The later the yield potential that we're going to have there as well. Mostly because the crop has less time to tiller. It's going to have less time to go through development. It's going to squeeze in crop development there. So besides being later, it's going to be shorter as well. So the yield potential kind of goes down with time. There's some research done in Northwest Kansas that shows that very limited yield potential. So if the crop is really coming up in the spring, we might have like about half of the yield potential on a normal year as compared to the crop that were emerged in the fall. Again, this is some research from northwest part of the state kind of showing that. So definitely, if we're able to get some snow cover and get some moisture coming up soon, you know, that'll be great and still help that yield potential. But the later it gets, the less yield potential we have out there because of a later and shorter season for that crop. What rates do you suggest applying for phosphorus with the seed? And are there any recommendations still in line with being able to premix to a week before planting? So usually we try to, you know, for phosphorus, we try to say up to about perhaps 30 units of P2O5 per acre. Is a pretty safe rate there. I know of growers who went well above that and had success. Even our small plot, we had done that pretty well as well. We just need to be careful with if there's any nitrogen and potassium together with those fertilizers we're putting in seed, they might cause some burn to the seedlings coming up there. About pre-mixing up to a week before planting, I would be more careful with that, especially if you have any nitrogen, again, nitrogen or potassium in that fertilizer. Ideally, I would like to see it in furrow rather than applied with the seed, if that's possible. Darwin had a question there. How much zinc sulfate can we put in with the furrow? Darwin, good to hear from you. Hope things are going well out there in Southwest Kansas. Yeah, that's a good question. I don't think I have a good answer for you on top of my head, Darwin. Zinc sulfate, how much can you put with the seed without injury? I don't really have a good answer for that, but if anybody in the audience has, I'll be happy if you can help Darwin with that question. So haven't done much work with zinc sulfate, Darwin, so I apologize. I don't have a good answer for you there. Very well. Well, I don't see any more questions popping up here. So thanks, folks. I appreciate the attention there. I'll be here until the end as well. So if you have anything else, feel free to throw it in the chat, and I'll be happy to address that.